system. Another aspect which comes is, how do I improve the performance? As we talked about in the first slide, that I need to maximize the generation. If I need to maximize the generation for the customer, I need to identify all points which results in loss of power with respect to the wind or the solar intensity which is present. One of the thing is, when we talk about is, there is something called as any turbine, there is a power curve. Power curve is a relationship between the wind speed versus the power which is likely to produce. And every turbine, this power curve gets defined. This is something which we have an agreement with the customer, that this is turbine, this model is going to follow this power curve. Now, while that is a characteristic power curve, but when it comes to the operation, it may not follow all the time at every moment. And if this particular variation is noticed, that means to say there is a loss of power which is taking place for that particular turbine. Now, the point is, how do I identify this? While the machine is running, everything is happening, it is generating power, but it may not be generating power as per this particular power curve. There are various methods which is being used. The point is that how do we reduce this whole time by which I could identify and clearly identify it? There should be no false positives and no false negatives, because if you tell a particular turbine, you send a mail, okay, these 4 turbines are not performing as per the power curve, you send to the site engineer, he finds, no, sir, everything is fine. This is a false information. So what happens is it results in loss of the confidence. We need to be very specific. Yes, this particular thing is having this particular issue, and there is actually there is a technical issue in that particular turbine. So the various methodologies are being utilized, and also it is important that what kind of a time period of the data sample we are taking. If we try to identify too quick, we may end up in large number of turbines which will have a problem. Maybe we may run out of the 10,000 turbine, we will say, okay, these 500 are failing. But if we actually see a consistent behavior over a week, those 500 may actually reduce to just 50 of them. Now we are more focused, we are more determined. But there is a trade-off on the other side, that we have lost, the loss or the units have been lost for that particular week. So we have to find the right mix and match and build our algorithms in such a way so that this loss is minimized, yet our identification is as close to the reality as possible. Another aspect which is characteristic of a turbine is that when it generates a power, the maximum power gets generated only when it is facing square to that particular wind. In case it is not facing square to the wind, it is deviated at an angle, the power generation gets reduced. Now, again, it is a question that machine is generating, everything is happening, you cannot visually make out, but overall there is a reduction. So again, you need to build that algorithm to identify where are such cases. And it has been found that 60 to 70% of loss of power is because of this slight deviation by 8 to 10 degrees from its actual angle. So there are various clustering algorithms, various neighboring algorithms, which is where you carry out a set correlation analysis to identify actually where is an issue. And it is not only that you can rightly identify this, you have to correlate with other parameters with respect to the terrain, relief, power produced, to actually conclusively come out, yes, this turbine is having this problem. And you can see this, that as we increase in the yaw misalignment, the production reduces considerably. Loss production goes up to, if you take 20 degrees of yaw misalignment, it goes up to loss production to 12%, which is a very, very huge in terms of number of units which get lost. Coming on to the next part, that is condition-based monitoring, maintenance, and the predictive maintenance system. Again, basic thing is that how do I reduce my downtime of a turbine? Whether we should allow it to run to failure, or we should understand the behavior before it fails and take some pointers, some leading indicators, which will give us, yes, this is likely to fail. And I do a planned action or a corrective action much before the failure actually happens. There are hundreds of sensors in the turbine which allows us to do this particular job. And analysis of those particular sensors which are giving out data at every milliseconds helps us in identifying those patterns and trends which will give us a certain amount of surety, yes, this behavior of this particular component or a system is deviating from its normal behavior. So this is a combination of various systems where it has a feedback loop, where it takes a vibration data, acoustic data, your oil data, and combining these data gives us the health of that turbine, how exactly the systems or subsystems are behaving with an integrated manner. When we look at the whole ecosystem of this particular thing, it is not only the sensors. What is more important in this is that utilization of the knowledge base. What is the past pattern? More so with the technical rules which our specialists or experts identify that if this happens, this happens, or this happens, this is a indication that this particular event is likely to happen or failure is likely to happen. If my temperature of a bearing is going to increase, my ambient temperature and front bearing temperature difference is greater than 10 degrees centigrade, my vibration is increasing, and there is a certain status code or alarm comes up, all these parameters, when it comes up simultaneously in a short period, that is, I can say yes, the probability of occurrence of a failure is 70% or 80%. To improve that probability of identifying a correct such event is very important, where the technology team, the engineering team, the analytics team, and the operation team need to sit together, make those decision rules, hard-coded into the system, and helps you to identify that particular pattern. So these are various patterns which emerges where we have what is our actual values, what is the predictive values, where there is a difference in that, identify those particular things, flag those outliers, carry out vibration analysis, spectral analysis, fast Fourier transformation, be able to give you that particular values, and then correlating with other parameters to give a more definitive matrix. These are such rules which we have tried to map, and over a complete set of turbines, we have identified 6 rules and mapped it to our system, which allows us to filter out a particular turbine or a set of turbines which were having this problem. Having identified those, then we can drill down. Otherwise, it is very difficult to identify from 10,000 turbines which is having a problem today. So we need to, instead of carrying out each one of them, put that rules into the place and be able to filter out and get that only those things. Having identified those particular turbines, one can go drill down into each of those events, identifying where are the gaps and correlating it with the ground conditions and then communicating it with the site team. So this becomes a complete feedback and a, I would say, integrated approach which allows us a more, I would say, fruitful outcome in the whole system. Another very important part is with respect to the wind farm siting and layout. As the person or the customer is looking for a particular investment, he wants that he should get the best site. He should get the best place where our turbine generation would be maximum for that particular amount he is investing. For that initial analysis, there is a complete modeling is done with respect to the wind farm pattern, with respect to the solar insolation, and there it combines all those fluid dynamics to create that wind farm model. So as that you allow that whole system should be such, those locations should be such that it allows you to maximize the profit for a particular customer. And when we're looking at it, it is looking at a complete life cycle of 20 to 25 years. How the pattern is going to be, based on what patterns have been there for last 5 years. So these simulations models are being run by specialist team of our group, and which carries out this modeling, which allows us to pinpoint that these are the locations which will have the highest yield. Any change of location by few meters results in change in the yield from these turbines. Because with respect to whether it is located on a hillock, how close to that particular relief it is, whether it is close to that particular escarpment, whether there is some cliff close to that, or there is any kind of a valley which is coming in. All those small changes in the relief affects the overall wind pattern, which affects the power generation of a turbine. Complex modeling happening on this, but it allows you to greater, these analytics tool helps you in getting a better resolution and a faster response time from the various model or the data sets which we have from the past. So these are the various layers of the data sets which get built on to carry out these particular wind farm siting and layout algorithms. When we say what exactly are we achieving it? First is, as said, we have to enhance the generation of these plants. We need to maximize these. So this becomes one of our KPI when we are measuring our any kind of a initiative or with respect to our performance of analytic model or in terms of an operational parameter. Second is that how much these costing model or reliability modeling or these condition monitoring system is allow us to reduce our operating cost in terms of manpower, in terms of heavy machinery deployed, in terms of cranes, in terms of our material consumptions, in terms of our change from breakdown maintenance to planned maintenance strategy. How many percentage-wise preventive maintenance by breakdown maintenance, how much we have moved towards preventive maintenance. Then is, can we build new products? Because customers becoming savvy on this, can we also align and partner with customers? Because they are also looking, they have invested heavily into this product. They would like to be aware of what is happening in their farm, what is happening to their power plant. They would also like a live feed of these particular data in the systems. They also want to understand the system behavior. So creating a product for them and then building it a kind of an ecosystem where we have a partnership with customers. And another aspect is very important is from all this is becomes a quality score. How good is our systems are performing? How good is our people at the site which is happening? All these things gets mapped through these various data points and the parameters which we store, analyze, and then build the dashboards or the KPI as part of it. Few challenges. As we have discussed that how do I reduce the response time, or rather I would say not reduce, but in terms of optimize the response time from identification of a particular activity or a fault or a occurrence of an event to complete resolving it. If we do it early, I may be actually doing it wrong. If I do it too late, my loss would be high. So what is that optimal risk? And it would be different for different cases. Then these systems which has come up, if you look at it, last 20 years we had different level of automation across different geographies. In India itself, when we take across the world, we have different level of automation. Integrating them, getting onto the same level, speaking at the same language becomes a very difficult and challenging task. Then comes is all the systems and data systems which are from a different sources, whether it is an SAP ERP or whether it is a data set from a wind mast, weather report, SCADA data, sensor data, maintenance reports, lifetime reports, all this we need to integrate so as to create one view for a particular turbine, for a particular wind farm. So with this, I come to the end. I thought I've been able to stick to the time. Thank you. Yeah, with this, I'm open for the question. Anybody would like to please ask? I know we are, next is the lunch, so I'm sure people would be quick and.
Yeah, this is Saujanya.
Yeah, sorry.
Yeah. And we do the same because I come from the GE,
Okay.
GE Power Systems. I
Right.
worked. And it's more related to me, this topic actually.
Thank you.
It's very, very nicely done. Okay. And what I want to ask is, what is conditioner based monitoring? Why do you call condition there?
Yeah. See why it's a condition is because what is happening is I am talking about a bearing, let us say. While bearing has not failed, but that bearing has started giving a vibrations which is more than what is supposed to be. If my vibration is increasing, I know that the roller's bearing or the races inside, the gap is increased. If the gap is increased today, maybe into a few thousand of mm, but will increase to, let us say, by 1 mm, by the time the damage is likely to occur. And it will actually create a huge amount of damage to the generator. So that condition which I am able to anticipate by having that signature of vibration will allow me to correct at a time much before than it actually fails.
Okay. Because you are monitoring continuously condition of the asset, that's what.
Condition of various critical components and major components.
Okay. Okay.
Yes.
And would you able to achieve any outcome of this one entire, what did you achieve till
Yes,
so
we
far?
have been able to achieve that when I have shown on screen where we have combined 6 parameters. One is this condition, then certain other statuses and certain other parameters combined. We have said if these 6 condition occurs.
No, my question is in the overall, you applied analytics in the power systems, renewable energies, and did you meet your outcomes?
Yes,
Like-
exactly. That's what I'm saying. That with that particular rule system, we were able to identify 8 systems where such problems are likely to happen, and we could rectify it before that. 8 turbines where we could conclusively identify, and yes, it was said yes, we were successful in correctly, positively identifying it.
I mean, you did predictive maintenance, you were
Yes.
able to detect the failure in advance?
Exactly.
Okay,
8 cases were there.
okay. And 10,000 turbines?
No, this is in the previous company that was 6,000 turbines.
Okay, okay.
Hi, this is Balaji from Ford.
Yeah.
Here. Is that CBM is input for CEP, complex event processing, or both are same?
No, they are 2 different things actually. Where we are talking about CBM is from a point of view of sensors data which is being picked up. So we have the sensors which are placed at a critical positions, and that data gets analyzed with respect to its actual what is supposed to be, and in relation with the other turbines how it's supposed to be. Within a group, within that particular turbine, so correlating with that, if all turbines are behaving in a particular group in a way, then our conclusion may be different. But if one is